So, you and your group wish to investigate the possibility of a small hydro project. What next? You will almost certainly at some point need to employ a consultant. Hydro systems are very complex to design, and it's very unlikely, even with significant engineering and project management experience in your group, that be able to do this alone. But even before you get to this stage, there are some useful investigations you could undertake. First and foremost, you need to identify a suitable site, one that would make the project economically viable. Above all, this means one with the right head and flow. If these factors aren't right, it's back to the drawing board. So, what are head and flow? The head is basically a measure of how far the water drops compared to how far it flows. If your river runs over pretty steep terrain, you can make an initial assessment of head from the contour lines of the largest scale of Ordnance Survey maps. For rivers with lower head, running on flatter ground, it's more complicated, and you'll need the services of a qualified surveyor with a theodolite. Understanding the flow pattern of your river is also important. What you're looking for is a river that flows fairly consistently over the year. What you don't want are sometimes described as flashy rivers, those that have a reasonable average annual flow but characterised by flash floods from periods of high rainfall. And look out for seasonal variations. You won't find it economical to put a hydroelectric system into a river where summer flow is reduced to almost nothing. You'll need data going back over as many years as possible to identify the flow patterns and plot these on a graph, a flow duration curve. This is one of the main tools for instantly assessing whether a site will be any good for hydro. Fortunately, there's a low-cost way of accessing some of this data. The UK National River Flow Archive at Wallingford in Oxfordshire has records of river flow data gathered from more than 1,300 monitoring stations in the UK. The staff at the archive are able to tell you how near your site is to one of their gauging stations, and for a fee of between £50 and £300, they can generate the flow data that you need, including your flow duration curves. The flow duration curve on the left is characteristic of a flashy river. The one on the right is of a river which would be more suitable for hydro. You can use the flow duration curves provided by the River Flow Archive to make an educated guess at whether your site is worth discussing with a consultant. Note that if your site happens to be some distance from the nearest monitoring station, the archive data may not be very accurate, in which case there are consultancies with software that can model the difference for your site at a cost of a few £100s. Whatever the outcome of your investigations into flow data, further measuring, possibly for a year or more, may be necessary for sufficient accuracy. Once you've identified a suitable site, you need to find out more about it. Firstly, who owns the land, and do you think you could enter into a purchase or lease with them? Is there a reasonable connection to the grid? If you are miles from any grid access or properties who might need to use the electricity, generating hydroelectricity is probably not going to be economical. Is the site accessible to machinery? And we're talking big lorries and earth movers here. A smallish turbine can weigh several tons. Who may be impacted by the project? The river-using community probably includes anglers, kayak clubs, wildlife enthusiasts, and more. Is there, or has there ever been, a mill on the river? If the mill house is still there, it could potentially be reused to house a turbine, and this may make gaining planning permission easier. You need to make sure that the run of the river hasn't been significantly altered since the mill was in operation, for example by dams or weirs being built elsewhere. Speak to people who have lived locally for a long time and consult old maps and photographs. Yes, to both. Planning permission will be required for any works along the river, such as building the weir and the turbine house. Even if there's an existing mill house, it's very likely that you'll need planning permission for the required alterations, and there is a reasonable chance that an existing mill house will be listed anyway. If it is, you'll also need listed buildings consent. Because all hydro projects will require works near riverbanks and altering the flow of the river, you will almost certainly be asked for an environmental assessment to accompany your planning application, so you'll need the services of an ecologist. Unlike other renewable technologies, where most of your permissions will be granted by the local planning authority, hydropower has another layer of complexity. You'll also need several licenses from the Environment Agency. These include an abstraction license, an impoundment license, a flood defence consent, and freshwater fisheries approval. They're not expensive, about £135 each, but each licence requires supporting evidence, such as migratory fish surveys. Such studies can only be done at certain times of the year, which you must build into your timetable. Many hydro projects fail or are delayed because groups badly underestimate how long it will take to get these licenses. And please, do not view the Environment Agency as an obstacle to be overcome. The Environment Agency has a statutory duty to protect and enhance the UK's rivers and to manage flood risk. They're not there to try to stop your project, but to protect the national river network. Their remit and responsibility is huge, and your project is a tiny part of it. Be prepared to work with them and to their timescales. Talk to them early and often, and you will get what you need in the end. You will also need to work with the grid operator to ensure that your proposed connection is suitable. Small projects can often be connected to the grid without permission, just by using compliant equipment. If your project is in a very rural area or is reasonably large, there may be a cost to upgrade the grid to take the new load. Dialogue with the grid provider should be started early, and you should keep them up to date so that any costs can be calculated into the project finances. Upgrading the grid to accept a new connection can be quite time-consuming, and in some areas you may need to put your project in a queue for this, so early and regular communication will help minimise this period. Hydro is said to be the most time-consuming of all technologies to get, from inception to installation, so be realistic with yourselves and with others. For even the smallest of systems, you should plan for a minimum of 3 years. Don't be put off. The rewards can be huge. If your site is a good one, hydro is a very reliable, predictable and long-term energy generation option. Operating lifespans of 50 years are not uncommon. A small system in a straightforward site could cost as little as £10,000 to get to the point of installation, with perhaps a further £50,000 to install. Bigger community systems could be in the low millions. But remember, part of the work you'll do with your consultant will be to establish the economic feasibility of the project as a whole. Though a project cost of more than £1 million may seem out of reach of a community group, this will be offset against significant operating income from electricity sales, and that should form an attractive investment for a bank. More information about project finance and legal structures is given elsewhere in this DVD resource. Hopefully, you now have the information to turn your ideas into reality. Thank you for watching.